Hello and welcome to Living Proof, the Isaac Newton Institute podcast. My name is Dan Aspel and I'm your host. Today, myself and Dr. Christie Marr are speaking to Rama Govindarajan of the International Centre for Theoretical Sciences in Bengaluru. Professor Govindarajan is the Kirk Distinguished Visiting Fellow for the Mathematical Aspects of Turbulence programme, and she has many insights to share about her research, contemporary mathematics in India, and much, much more. We hope you enjoy the episode. So welcome to Living Proof. So Rama, it's lovely to have you here.
Thank you, Dan.
And on the mic as well, we have the Deputy Director here at INI, Christie Marr.
Hello.
Hi, Christie.
Hi.
So, as an introduction to you, Rama, you are a programme participant in the Mathematical Aspects of Turbulence programme, which is ongoing at the time of release here at the Institute. How long have you been here now? How many months have you been here?
So I came in early March and I'll be leaving in the end of May. So it's been like it's a 3-month visit.
Excellent. Yeah, which means that you're just over halfway through your time here?
Yes.
And how are you finding your time here so far?
Oh, I've been enjoying it to the utmost. It's been probably my most productive scientific trip ever. And there's a lot of people who are very much in my area of work and I'm learning a huge lot from them. I'm enjoying talking to them.
And there have been workshop weeks as well as the sort of general weekday activities of researching and being in one of the rooms here. So a mixture between time to think and work on whatever it is you're focusing on and time for some quite intense socializing.
Yeah, that's actually a very nice and very important combination. So like during the week when there's a conference going on, we're listening to talk after talk, but then we can meet the speakers later on and go over it in a very good way. We can work on the blackboards. The blackboards are the best, by the way. And so we can work out, all the things, all the questions we have in some detail, and that often leads to further work or new ideas.
Yeah, that's very positive to hear. Christie, did you want to leap in with one of the many questions we have about Rama's work and indeed her background as well, which is fascinating?
I would love to do that. So I was wondering really what drew you to the field of turbulence, and I had been speculating whether growing up in Chennai and experiencing the Indian monsoon led to your fascination with the field of fluid mechanics and geophysical flows and things.
Okay, so I actually came into this field by accident, I should say, because when I was doing my undergraduate in engineering, I was like any other person in my class, like all of us wanted to get high-paying jobs right after graduating, and I was in that mode as well, so I never considered research because it's not high-paying. But then I got slowly drawn into it, partly because I got married at a relatively young age of 23 and a half, and I was in Bangalore. And in Bengaluru, in those days, research was one of the best things you could do if you wanted a career. So that's how I moved into research, and I'd always liked fluid mechanics, even as an undergraduate. And in my master's in the US, I had, gone through a lot of teaching experience in fluid mechanics. So that made me more, more immersed in the subject, you can say. And fortunately, there was a very nice guide, a very well-versed in fluid mech and very good in science person, Rodam Narasimha, who agreed to take me on as a PhD student.
Wonderful.
In Bengaluru. So
thank you. And am I right in thinking that you had a very tiny baby when you started your PhD?
Yeah. So this is a strange thing which happened, which is that, when I was trying to apply for a PhD, I noticed that the date of the interview was coinciding with my due date for the baby. So then I went to my gynecologist. I got a letter from her stating that this is indeed the case. And then I went to my advisor, the person who's going to be my advisor, he also wrote a strong letter saying I need an interview early. So the idea was that they would prepone my interview for me, like hold it a month in advance. So the head of the department agreed to this, and he and 7 other professors, they interviewed me 1 month before the due date, and this interview went on for about 75 minutes. And you can imagine I was in the 9th month of pregnancy, very tired. I was writing on the blackboard for 75 minutes. But because it was an interview that was put together just for me, it went on for so long. Normally, students are interviewed for much shorter times. So then, the day before the actual interview, I got an information that the authorities had actually annulled that interview, which was conducted by the head and 7 other professors. And they said this interview is illegal, so you have to come on the right date. So then fortunately somebody sent me a message that if you don't come in tomorrow for the actual interview, you will not be considered. So then that night I went into labor. I went and got admitted in the hospital. And then in the morning around 9 o'clock, the gynecologist came and said, oh, Rama, I see that your labor is not proceeding very fast. So I think it may even be tomorrow when you get your baby. So why don't you go to that interview?
That's the most incredible story.
So believe it or not, like I'd been sweating, I was in pain, and I didn't even take a shower or anything. I just changed into some clothes and went to my interview. And it was a subset of the same 8 professors who had interviewed me in such detail like 1 month ago. So what more would they ask me, right? But then I was in such pain that I don't know what really happened. I know that this interview lasted for 10 minutes. And I couldn't really understand the questions they were asking. They were asking easy ones, like they asked me to plot e to the power x. And then in the middle of my pain, I saw this big E, white E. And I thought, oh, I've seen this before, but I don't know what it is. But then out of instinct, I plotted the right plot, because we've plotted e to the x so many times, right? So I don't know what else went on, but this was my actual interview. And in the end, when I was graduating, I went in to pay some fees or do something, and I saw my file. And in those days, it wasn't computerized, right? It was on paper. So the first page of the file contained my request letter for an early interview. And on that, somebody in authority had written deny in green ink. And then below that, they'd written, this will create a dangerous precedent.
Wow. Well, you set many wonderful precedents, I have to say. So are you able to talk to us a little bit about, that's just an incredible story.
I was thinking as well, aside from all the other elements in that, which add up to an incredible tale that would make a fantastic opening scene for the movie of your life as well, I think. Did you ever find out the reasoning behind the person that had written that note on the previous interview?
No, in fact, in those days, I didn't have the courage to follow it up. But I was just happy that I could, actually go in for the regular interview, and I made it that year. Otherwise, I would have lost a year.
So were there, I'm presuming because of their use of the word precedent, that there weren't any other women who had been accepted for that PhD?
No, there were women who were accepted for the PhD. It would create a dangerous precedent of acceding to requests to change dates of interviews.
Right. Yeah,
he did not want to change the date of an interview for anybody or anything. That was the point.
Yes, that's astonishingly difficult to understand, isn't it?
Yeah.
Well, particularly given the circumstances. One can understand not necessarily wanting to move dates, but there are circumstances where you can't shift things.
Yeah.
So would you be able to talk to us a little bit about, because I know this is something that lots of women face, is juggling having a baby and their studies. That would be really something I'd love to hear you touch on.
Okay, it's obviously not easy. It's obviously not easy whether you're a man or a woman, if you have a small baby and you're trying to do your PhD. But sometimes circumstances throw us in that and we have to manage. So that happened to me as well. And maybe it's a little additionally hard when you're feeding a baby. And that is particularly a woman's thing. So yeah, it ended up that there were some nights when I didn't even enter the bedroom, let alone think of sleeping. So I had to study through all night and care for a baby and go for my exam.
Amazing, 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 Rama. On a related note, but obviously this wouldn't apply to the newborn baby when you're feeding them and things, but I've read in a few places about you talking about symmetry in the home and equal roles of parents and things. And I would love to hear, I think this is really inspiring for future generations, and I'd love to hear you talking a little bit about that.
Yeah, so I think, a lot of arguments about whether women should be in science, whether this, whether that, could be sorted out if we just thought of that one word, symmetry. Like we could just think of it the other way around. So like last week, for example, I was asked to speak online in one of the institutions in India. And one of the questions that was asked to me was, what do you think is the role of women in nation building? So I said, have you ever worried about the role of men in nation building? So it's as simple as that. Every time you think symmetry, then it almost seems hilarious sometimes, the kind of questions that are asked or the kind of things. So in India especially, I always advocate for symmetric treatment of sons-in-law and daughters-in-law. So a lot of parents nowadays want to treat their children equal. So you'll see that there's not much difference in the way they bring up their daughter or their son. But this hasn't carried over to the situation after marriage. And it's very, very different how they treat a son-in-law and a daughter-in-law.
That's very interesting. And perhaps that's just generational. Perhaps the first step was to treat sons and daughters
possibly
in a more symmetrical way, and maybe I'm an optimist.
Right.
Maybe that will come in time. And with
I do think so.
Raising of consciousness, I think you have to ask that question of people. So people now think I must treat my son and my daughter in a similar way, but now you need to ask that question again. Do you treat your son-in-law and daughter-in-law in a different way? And I think it'll make a lot of people reflect and think perhaps they don't.
Yeah, it's such an excellently succinct way of putting it, focusing on that one word. I have to say, I think that's very effective.
Right.
And one thing I'm curious about, I don't want to move too far away from this topic, but from your CV, as I can find it online, your professional career, I'm sure that you've had many travels elsewhere, but has been divided between India and the USA, because the two universities I think that you've attended in the USA were Caltech and Drexel. Is that right?
Yes.
So your education took you to the States, and you've returned to India. Has India always been the focus of your professional career, and have you always wanted it to be? Have you ever been encouraged or sort of internally motivated to move away from your home country, or do you feel like you have a lot to give to India? I'm curious about your motivation for focusing your career in your home state country.
Okay, so first of all, I haven't spent very large amounts of time away from India. So although I did a master's in the US, that was 17 months, and my postdoctoral fellowship was less than a year because I had to come back for the delivery of my second baby. So I didn't spend very large amounts of time in the US. That being said, I like the US. I enjoy being there. I like the UK. I like, being in all of these places where life is good and I learn a lot about science. Despite this, I've always thought of India as my home, and I've wanted to do science over there. Although at least in those days it wasn't as easy as it is here. So even now it isn't as easy, but it's a lot easier. So I've always thought of that, and I've enjoyed it. In some sense, I feel that I got some additional satisfaction out of doing this in India than doing it outside. partly because I could bring in a new subject. In those days, there weren't so many people working in fluid mech, in the kind of fluid mech that I was doing. There were people who were doing other specific things, but I could bring in something which wasn't there, and I could help students do good PhDs.
Yeah, that's really fascinating to hear. I suppose I'd just love to hear more about that, because I think perhaps a lot of people listening to this podcast will be fairly familiar with the mathematical scene in Europe and North America. But could you paint us a picture of what the mathematical scene is like in India, especially in comparison to Europe and America, where you also have experience?
Okay, so like I can't specifically talk about the mathematical scene because I'm not a math person. Technically, I am a fluid mech person and an engineer. Actually, all my education has been in engineering, but I'm now in a physics department. So, yeah, I can't tell you specifically about the math scene, but I can tell you about the research scene. And it's like incredibly optimistic. Compared to 30 years ago, like Indian science is really burgeoned out in terms of numbers, in terms of quality, in terms of ambition. So it's really a thriving atmosphere now, I would say, compared to 30 years ago, for very sure. And at the same time, there's a long way to go. There's a really long way to go, and we have to help cross that bridge.
And your current role, I will have already said this in the introduction, but I'm aware that we haven't said it while speaking to you, is at the International Centre for Theoretical Sciences in Bengaluru.
Yes.
And can you tell us a little bit about that as a centre, about what it's like to be there?
Okay, I'm absolutely delighted to be there. It's like the most amazing place. It's a small place, like there's about 20 faculty members and a commensurate number of students and postdocs. Everybody is very high quality. Some of my colleagues who are way, way younger than me are so scarily good that it's amazing. I just love talking to them. I learn a lot from them. Similarly with students and postdocs. So it is a place with a three-pronged ambition. So one of it is research, and then there is outreach, science outreach to the people. And the third one is very similar to the Newton Institute here. It is to do programs. So if you look at our site, you'll see that there are long-term and short-term programs going on all the time. And anybody in the world can apply and come and host these programs. And we have a pretty nice setup for running them.
I'm sure that Christie will have some excellent questions coming up, but if I can just bring it back to our original topic after your excellent answer there. So you encountered a lot of intolerance of pregnancy earlier in your career. How do you feel now? Do you feel that you still meet these attitudes, these negative attitudes about women in science?
So obviously I don't at this stage. There's two reasons for that. One is that India has changed a lot for the better in those things. For example, a young woman asking for a change in interview date, I think would automatically be given it. I mean, it wouldn't even be an issue. So a lot of those things I faced have actually gone away because people's attitudes have improved a lot since then. And secondly, as an older person, it's easier to, bypass those problems. But I would say that in a place like ICTS, it's amazing. Like you have people with all the right attitudes and you'll never face anything. So it's a very supportive environment.
And I think that echoes what we're trying to create in maths institutes across the world, and certainly at the Newton Institute. I really hope that everybody feels welcomed, no matter what.
I've faced very warm welcome and very nice stay here. So I really need to compliment you on that. It's also perfectly ironed out. Even the smallest things are thought of.
I love that, and I've loved your contribution to the programme, and you're so modest about your achievements and your backgrounds and things, but you've won an outstanding scientist award by India's National Aerospace Laboratories and things like that. You're such an impressive scientist, and yet you're so modest, and I see you working with the younger researchers on the programme, and I see you really inspiring them. And I think that's just been a real joy that I have found over your time during the Institute.
Thank you, but I think I have good reason for my modesty. Like, I can see so many scientists so much better than me. I think I know how to rate myself.
Exactly what I said. You are so modest, Rama. I would love to ask you a little bit more about the field of turbulence. I think there's something very exciting about it. It's such, it has so much history. It goes back, centuries, and yet there are still really demanding unsolved problems in that field. And I'd love to hear you talk a little bit more about what excites you about turbulence, about, fluid mechanics, what makes you just long to still tackle and solve the next problems, to think of questions to ask, even if one can't always find the answers.
Okay, first of all, fluid mech is a brilliant area. So there's, questions which were tackled centuries ago, which are still relevant. There's new questions which come up every day, and there's relevance to every field you can practically imagine. So I was just telling somebody this morning that when I go to speak about fluid mech to, let's say, high school students or people who don't know what it is even, so I spend a few minutes saying, oh, all of this is fluid mech, the oceans, the atmosphere. You try to understand, the dynamics of these things, and it goes all the way down to swimming microorganisms or even formation of planets. So it's like it spans all the scales and everything. And then I asked the school children, can you name one sport for me in which fluid mechanics is not important? And usually there's they talk about it for a while and somebody or other comes up with chess. And very soon after this, there's usually another kid who pipes up and says, chess has to do with fluid mechanics because blood needs to rush into your brain.
Brilliant.
I don't know whether blood rushes into the brain or whatever, but fluid mech is all encompassing. So you can see that whether it's biology or sport or the climate. So you have a range of problems to choose from. And almost all these problems are unsolved. So you asked about turbulence, right? Turbulence is a very nonlinear phenomenon. So when something is nonlinear, it means that even the tiniest scale, like motion on the scale of, a few millimeters, can change what's happening on the scale of kilometers. So you'd have heard about this butterfly flapping its wings kind of thing. So it's a very chaotic process where every scale affects every other scale. So this itself makes it complicated. Secondly, given today's computers, unless something phenomenal happens in quantum computing or something very dramatically different happens, you're going to be in a situation where computers are highly inadequate to solve this problem, even the world's fastest and most parallel computers. So what people normally do is they study the large scale separately, they study the small scale separately, and then they have some tie-in kind of forcing, which you learn something from small scales and feed it empirically into the large scale simulations and vice versa. Now, this has been shown to be very unsatisfactory. So there's this big gap of how to solve these problems. So even if you know the equations, you know everything, you can't solve these problems very easily. And that's why you have so many different claims about the climate, different predictions, things where things don't agree. So there are open problems of enormous importance. This is one aspect of the open problem that I told you about, but there's questions you can ask in basic math. Like there's pen and paper equations you can write and solve and understand new physics. So this kind of captivates me. I like breaking down a problem into its simplest terms and maybe writing it on pen and paper and solving something. And I feel very, very happy when I understand something on pen and paper which hasn't been understood before. And that thing can then be made more and more complex and its signature can be seen in the big system. And I love that.
That's really fascinating. You've preempted exactly what I was thinking while you were speaking, because we've had so many guests on this podcast who have expressed a love of anything that you can prove definitively. And that's the attraction of mathematics for a lot of people. You can create a successful theorem and it will always be true.
Right.
And when you were describing fluid mechanics and what seems to me to be something almost unknowable in its totality, but you do still find a satisfaction from taking it down to the smallest details that you can be certain about, and then applying those to the chaos, for want of a better word.
So I should also emphasize that when we pull things to their simplest terms, we're making lots of approximations. So I, at least in the work I do, don't prove anything. But under certain approximations, I'm able to bring out some simple physics. So that would be more like what I do. At the same time, there are many things we can understand about turbulence. It's not as hopeless as it sounds just because it's chaotic. One important thing to note is that on the mean, things are predictable. So, there's slowly changing mean behavior, which can be predictable in some sense. And there is these rapid things which cannot be predicted. So, for example, if you ask me what will be the temperature on a certain day 50 years from today in a certain place at a certain time, I think nobody can answer that. But if you ask what will be the trend, that kind of thing can be answered to some level of accuracy, which is why we are in this game of predicting. So it's not all hopeless. That's one point I want to tell. So you can see a simple example. So suppose you have water in an underground sump which you pump up to your overhead tank. Then every month you can kind of predict your electricity bill, right? So that means on an average, it's doing the same thing.
I'm often reminded when looking at programs across the board here of the George Box quote, and I might get it slightly wrong, but it's something along the lines of all models are wrong, but some are useful. And I think that's just lovely. One chooses what approximations to make things sufficiently simple to be able to analyse them, and but not too complex.
Yeah.
So, and it's that balance, isn't it, of knowing where to make the approximations and where to go into greater detail.
Yeah, so if you're able to do something nice and derive a simple equation, that's definitely very, very rewarding. And knowing that is a nice thing, even if it's for one class of problems or one little thing.
From my impression of the general mixture we have in programme participants, because the organisers always put a lot of thought into who they invite and how they may interact with one another, how do you think that your experience and expertise mixes with the sort of group of long-term programme participants as a whole? There must be others who are quite different to you in terms of their specialisms and experience.
Yes, so very much. So you brought up this thing about math people who prove things. So there are people like that in this program who I learn a lot from, and it is a very widening experience to see how they approach their problems. I may never approach a problem in that way, but it shows me, some directions which I may use. That's one aspect. Then there are people who do beautiful work in wall-bounded turbulence. So that group has been amazingly useful to me. And so they look at, simple structures. They're not quite simple, but they're simpler than real turbulence, which come repeatedly in wall-bounded flows. So the fact that there are walls is very important to this kind of pattern that you repeatedly see. So you see elaborate periodic dances which keep happening. And so those are things I'm learning about here, like how you go about obtaining those and things like that. So these are just two examples, but the kind of work that I do is on particulate flows. There's some people who are doing particulate flows with whom we're actually collaborating or talking of collaborating. So for example, how do microplastics get distributed in the ocean by turbulence? So that's one question which I'm discussing in great detail with one person here. There's another aspect which is the particles when they move in turbulent flow. So it could be microplastics, it could be little creatures in the ocean, it could be dust storm things, pollution, a variety of things. So then how they move in the ocean, depends on the forces that are acting on them. And there's one special force called the Bassett-Boussinesq history force, which a lot of people neglect because it's difficult to compute. And we came up, actually I should give the credit to my younger colleague Vishal Vasan. We came up with a method to solve for this particular force and not neglect it anymore. And we showed that it's important. And this has generated interest in some of the colleagues, especially like math people can now, solve this thing in a much better way than I can. And so this conversations are helping a lot, these Blackboard conversations on things like that. So these are just two areas. And then I look at flows where viscosity is varying as a function of space. And that is relatively, not too many people in this meeting are looking at that, but they look at flows where viscosity is a constant. And for them, it's like one step away to look at viscosity variations in their kind of flows. And almost any flow is viscosity varying if it's heated or if there's salt or sugar variations. Like the ocean can have different viscosity at different places. So yeah, or even it could be turbulent viscosity, eddy viscosity, which is varying. So this is another area where people are interested in my work. So it's a give and take, much, much more take than give.
I think not, but it's just brilliant. And so are there new collaborations that you've made while you've been here that you're going to take away with, for the rest of your career and things, do you think?
Oh, definitely. Definitely, it's been really beautiful. There's several things which we're talking about with several people. Of course, at this stage, it's all nascent and I can't predict which one will actually come up with beautiful results. But we are certainly seeing nice directions to move in. There's several of those.
That's really exciting. That's lovely for me to hear as well. And I'm hoping that, in 5 years' time, you'll be back in the Institute and you'll be able to tell us how some of these early relationships then blossomed.
Thanks for your wishes. I'd really love that.
It's fascinating to hear of progress of that kind being made during the programme as well, because it does happen relatively often, but most of the time the outcomes of the programme come in months and years afterwards. So actually a month and a half into your time here to be already helping people solve for previously problematic things it's wonderful to hear about that.
I don't know whether I'm helping people solve things, but at least I presented a new way of thinking about a problem.
Yeah, exactly. What more can anyone do at the Institute? That's fantastic.
And I love again that how we're bringing different communities together, and I think as you've alluded to earlier, it's how you can ask questions which can challenge the mathematicians and make them think in a different way, and equally the mathematicians are showing you things and making you think about your working in a different way, and I really love how that happens here at the Institute.
Yeah, it's an amazing place for that reason. And fluid mech is a topic which lends itself to that because everybody from a very pure mathematician to a climate scientist can contribute to the same field, and by talking to each other we gain much more.
Something that I love is that you go out and you talk to children and you care about outreach and things like that, and for me your work is so important and something that the next generation will really care about so much, about microplastics and about the environment, about the weather, things like that. And I think there's so much resonance for what you're doing, for what issues that children really care about.
Yeah, thanks for that.
And do you want to talk a little bit about that, about your outreach work at all?
Okay, so I haven't done as much outreach as I'd like to do, but at the same time, I try not to turn down any invitation in any college or school and try to go and speak there. And usually I find amazing reception and amazing interest from the kids and the young college students. So that's always been rewarding. I've tried to do a few lectures on women in STEM. So people ask, and one thing I do which is the following, that when women approach me, like a young woman approaches me, I never say no. So I always talk to them, and often I'm not able to help in solving their real problems, but at least I can give them some courage or some confidence or encouragement.
That's wonderful to hear as well. As we sort of begin to wrap up, because you've been very generous with your time this afternoon, I don't want to keep you away from this research for much longer. Could I ask a slightly more prosaic question, which is, how are you enjoying your time in Cambridge?
Oh, I'm loving every minute of it. I've done quite a few long walks here. This weekend I'm going to do punting. And I also went to Imperial College on one day. So I went to the Natural History Museum. And I went on the Cambridge History Walk.
Wow.
Yeah, lots of things. I'm enjoying every minute of it.
That's lovely to hear. So I think that was all we wanted to do for today. Fantastic. Well, Ramar, it's been wonderful to talk to you, and thank you for sparing your time.
Thank you, Dan, and thank you, Christie. It's been a great opportunity. It's very kind of you to host me for this.
And I hope the remaining month and a week or thereabouts is very exciting for you and full of the same kind of progress. So here's to the remaining time.
Thank you. It's always such a joy talking to you.
Yeah, great joy talking to you. Thank you.